All right, so let's just do a little bit of revision. So if I say y equals mx plus c, what kind of equation is this? This is a linear equation. Is this positive or negative?
Positive.
Why is it positive?
Okay.
The x is positive?
The n is.
Okay, m is positive, right? So whatever number is in front of m, that number tells us whether it's positive, or if it's negative, it'll go in the other direction. All right, y equals x squared. What kind of equation was this? Quadratic, good. So what does a positive quadratic graph look like? A smiley face. What does a negative quadratic look like? A frowny face. It's all very sad. All right, y equals x cubed. What's that called? A cubic graph. Does it start? Oh, this is let me just erase the board because it's in the way, isn't it? Okay, so does it start? Does the graph start in the top left or bottom left?
Bottom.
Bottom left. Well done. It does. Well done. No, I'm kidding. All right. And if it's a negative, it's going to start in the air and go down like that. What's this one called? Quartic. Well done. Okay. And what does this look like? It's an M. So what does this one look like? W. All right. Oh, that's a terrible drawing, isn't it? It shouldn't look like that. It should look more like that. All right. So these ones are all positive. These ones are all negative. Okay. So the general shape of the graph is important for us to know. Let's look. Oh my goodness. So let's look at a couple of other ones. So some of the weird ones that we talked about. Oh, good. Well done. Exponential. Okay, let's do that one in a minute. Exponential graphs. Does anyone remember what they look like? Quite half there. Right. So it's either looking like that, or it's looking like that, or it could be looking like that. Okay, so what did we learn in the last topic that reflects this? Okay, good. So exponential. Both of you. Growth or decay. And as Helen said, this is also compound interest. What's the other thing we looked at? No, sorry. I mean the other equation. So compound interest is growth.
No, I was scared to over 100.
Wrong one. That's the simple interest one. No. I'm not asking for the next graph. I'm still on this one, guys. I have not moved on. Hey. Okay, so what is that? What's that called? Okay, decay, or there's another word I'm looking for. Depreciation. Whoever said that, well done. So compound interest. So we're exponentially growing or decaying, which can also be depreciation. Depreciation. Well done. All right, now, whoever said, was it you who said, yeah? So what was it again? What was it called? Reciprocal. Gosh, I can't speak around reciprocal. Reciprocal. I did not spell that right. It's no, oh my gosh, what is wrong with me? Reciprocal. Okay, reciprocal. All right, so what do they look like? Yeah, good. So like whoosh and whoosh. Excellent. Or they can also look like this. Okay, so one of the things we talked about is we discussed a little bit about why this works. So what's half of 2? What's half of 1? What's half of half? Why are we doing decimals? What's half of a quarter? An eighth. What's half of an eighth? 1/16. Okay, you get the point. We're never going to hit 0. Guys, listen, okay, you need to learn a new word here. So we're never going to hit 0, right? So what this means is we are forever approaching 0 without ever hitting it. And that means that 0 is called an asymptote. So this is the fancy new word that we need to use. The asymptote in this case, so if I was going to draw this one, so if I drew my axes here, the asymptotes in this example here are x equals 0 and y equals 0, because they are forever approaching 0 without actually hitting it. Now, they don't have to be like that. You could draw an equation, like you could draw your axes like this, and this would be, your asymptote would be over here and over here, right? So that's okay. You do that more next year. I wouldn't worry too much about it. 1 over x. I'll do that in a second. So what this means is your asymptotes have shifted to the left and down. It's just wherever the graph is approaching without ever hitting it. Okay, I'm going to zoom in a bit because it's not very helpful, is it? All right, so let's look at the equation for this one. Let me change color again. So this is going to be y equals 1 over x. So in a reciprocal graph, the variable is on the bottom of the fraction. Where is the variable in the exponential graph? What do you mean by up the top? No, you're right, but it's more specific than that. Where is it? Think about the compound interest formula. Where is the variable? The power. Okay, so it's the indice or the power, the exponent, whatever we're calling it. So in an exponential graph, the x is the indice. In a reciprocal graph, the x is on the bottom of the fraction. So remember, my first question on the test is going to be you mixing and matching graphs. So if I write an equation where x is on the bottom of the fraction, it doesn't matter how complicated the formula is. If the x is on the bottom of a fraction, it's going to look like this. If the x is a power, it doesn't matter what else is going on. It's going to look like one of these, right? Where it grows forever in one direction or shrinks forever in one direction. Does that make sense? Not the band. All right. So what we're going to do is just do a quick practice of a difficult graph. Actually, let's do an easy graph and then a difficult graph. Okay, so let me just zoom out and say, whoop, that's not what I meant to do. You're welcome. Okay, let me just save this. Okay, let's do an example of graphing using a table of values. We'll do a quick, easy one, and then we'll do a difficult one.